Okay, these are notes for section 1.4, pairs of angles. The objective for this lesson is to first identify adjacent, vertical, complementary, and supplementary angles, and then using that information to be able to find the measures of pairs of angles. Okay, again, here's your vocabulary. We'll go through these as the notes continue. Either write them all down now or write them down as we go. So real quick, this you do not need to write down. Many pairs of angles have special relationships. Some relationships are because of the measurements of the angles in the pair. Other relationships are because of the position. So we're going to be looking at two instances based on the measurements of the angles and then based on the position of the angles. So the first one is adjacent angles and the second one is linear pair. First one, for adjacent angles. Adjacent angles are two angles in the same plane, so they're on the same piece of paper with a common vertex. So notice over here, 1 and 2, they share this vertex. If you want to call it a point, we can call it point A. They share point A. So because they share a vertex, they are adjacent angles. But no common interior points between 1 and 2. So they share the vertex and they share this common side. They share one side and a vertex, nothing else. There's no other points in between that they share. So basically, if they're side by side like this, they're called adjacent. Okay, the next set of pairs is your first buzzword is linear. So linear pair, buzzword is linear. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. So notice they do share this point. We'll call this one B. They share the vertex B as they do with the first one, and they do have that common side, but notice what happens with these two sides. This is a side and this is a side. These two sides form an opposite ray. So because it forms a straight line, we're going to call it linear pairs. So these ones do not form a linear pair because the lines don't go on and on. If I would have drawn a line out like this, perhaps a little better than that, then that would be a linear pair. But this one is adjacent because they don't form that straight line. And this is a linear pair because they do form the straight line. So 3 and 4 form a linear pair. For linear pair, go ahead and write this down as well. We're going to call linear pairs the T angles. Because if you notice, they kind of form this upside down T. So if I went over here, and here's two angles, let's say 5 and 6. 5 and 6 form this T, so they are linear pairs. Whenever you see a T with that perfect bar across the top, it has to be a perfect straight line, then they're a linear pair. So whenever you see the T, they're linear pairs. All right, so the first example is to tell whether the pairs of angles are only adjacent and a linear pair, or neither. So the first one we're going to be looking at is angle AEB. So trace AEB out, start at A, go to E, go to B. There's no point here because there's a lot going on, but when it says E right here, it means there's a point there. So a lot of these examples, you're not going to see an actual point like you do on A, B, C, and D. They're just going to be, when angles form at a vertex, they're just going to put the letter there. So there is a point right here. So angle AEB is right here. I'll call that angle 1. And angle BED is right here, BE to D. So I'm going to put a little arc here just so we know that it's the whole angle. We're going to call that angle 2. And so if you look here, here's angle 1 and angle 2. They have this straight line, so they form the T, so they are linear. And because it's linear, it's also adjacent. That's why they put this adjacent and form a linear pair. If it's linear, it's going to be adjacent, so we can just go ahead and put linear and adjacent. Okay, go ahead and try to do this one on your own. Pause it, write it down, pause it, and then check your answer. Okay, so first I'm going to measure out AEB, or mark out AEB. So here's A, here's E, there's B. AEB. Call this angle 1. BEC is right here, B to E to C. This is just this little angle right here, so we'll call it angle 2. So first, I see that they share E is the vertex in common, and I see BE is the common side, so I know for sure it's going to be adjacent. But does it form a linear pair? Do the two angles make that T? So this would not be a perfect straight line, so it does not form the T. So we're going to say adjacent only. Okay, so for this one, we're going to look at angle DEC and angle AEB. So first I need to see if they share a common side. They do share this vertex E, but they don't share a side. They need to share a side to be adjacent. So it's not going to be adjacent. And because it's not adjacent, it can't be linear. Plus we can see, so they do form this straight line here, but because it's not adjacent, it's not linear. So our answer is going to be not adjacent, or neither. Okay, our next two words are complementary angles and supplementary angles. Supplementary, the word supplementary is going to be your second buzzword. So first, complementary angles are two angles who add up to 90 degrees. So looking over to the side, please draw these three angles down as accurately as you can with the letters and the same numbers I have here. So A and B are complementary because they're two angles who add up to 90. 37 plus 53 is 90. So complementary means they add up to 90. Supplementary are two angles whose measures add up to 180. So if you look at C is 127, A is 53. If I add C and A together, I get 180. So because A and C equal 180, they are supplementary. So to find the measure of a missing angle, if they only give you one angle, say they give you angle A is 45 and they're asking you to find angle B, so it's complementary. The way you would find B is subtract A from 90. So if they give you one angle is 50, to be 90, I need another angle to be 40. So that would be 90 minus 50 gives me the 40. So same with supplementary. Please make sure you have both of these down. You can find the supplementary of an angle by subtracting 180 from whatever angle they give you. So if they give you angle 1 is 100, and they're asking you to find angle 2, so 1 and 2 are supplementary, you would just subtract 180 minus the 100 that they gave you, and you would find angle 2 is 80. We'll see some examples here in just a minute. So example 2, finding the measures of complements and supplements. They want you to find the measure of the following angles. So for A, they want you to find the complement of angle F. So what I'm going to do is I'm going to do 90 minus x degrees. This is the formula that they give you. They give you F is 59 degrees. So I'm just going to substitute this 59 degrees in, put 90 minus 59 degrees. This gives me 31. So the complement of angle F would be 31 degrees. So if I had an angle of 31 degrees and I call it angle H, angle H and angle F are complementary. Okay, next I want you to find the supplement of angle G. Go ahead and try to do this one on your own, and let's see if we get the same answer. You're going to do it the same way that you did up here, except you're going to put in 180 instead of 90. And instead of 59, you're going to put in 7x plus 10. I'm going to put 7x plus 10 in parentheses. That way I remember to distribute my negative. So I'm going to subtract everything. I need to subtract 7x, and I need to subtract 10. Let me combine all my terms. 180 minus 10 is going to give me 170. There's no other x term, so I just leave that. So this is the angle of the supplementary. So because they give you a variable in your original angle, your supplementary is going to have a variable as well. So this is your final answer. Okay, so this one's a little confusing, so you might have to rewatch this one a couple times to understand what's kind of going on. So they want you to use complements and supplements to solve problems. So an angle is 10 more than 3 times the measure of its complement. Find the measure of the complement. So we're going to use angle A and angle B. We're going to let angle A be our x degrees. So then angle B, since it's complementary, is going to be 90 minus x, whatever x is. So now I have to address this 10 more than 3 times the complement. So now all I'm going to do is bring down my x for everything. So I'm going to say angle A is 10 more than 3 times the complement. So now I'm just going to put in everything that A and B stand for. So x equals 10 more than 3 times the complement. And now I'm just going to distribute and solve for x. So solving for x, I get x equals 10 plus 270 minus 3x. This 270 came from the 3 times 90. This came from the 3 times negative x. Now I'm going to solve for x and combine these terms over here. So 4x equals 280. Divide both sides by 4, and x equals 70. So x degrees is 70. Up here, we said x was our A. So angle A is 70. They want to know what the complement of that angle is. So then to find the complement, you're just going to take 90 minus 70, and that's going to give you your final degree measurement. All right, so for the last set of definitions for this section is vertical angles. Vertical angles is your third and final buzzword. Vertical angles are 2 non-adjacent angles formed by 2 intersecting lines. So similar with the linear pairs, how we called them our T angles, we're going to call vertical angles our X angles. So if you notice, 1 and 3 are vertical angles and 2 and 4 are vertical angles. They form an X. So if I'm looking at 2 and 4, they have to be 2 perfectly straight lines. This is not going to be considered an X. It kind of looks like an X, but only this line is a straight line. This is not a straight line. So this would not be a set of 1 and 2 here would not be a set of vertical angles. But because these ones over here are straight lines, the opposite sides are the vertical angles. So when you have the X, the 1 and 3 are vertical angles, and the 2 and 4 are vertical angles. Okay, so for the last example of these notes, they want you to name the pair of vertical angles. So again, here at M, this is a point here where they intersect. There's no point showing you because there's already a lot going on. So unlike H, L, J, and K, they're not going to put that point there, but there is a point here. So first they want to name a pair of vertical angles. So I see that this does form the X, so I'm good on this. So now I just need to look at, I'm going to label these 1, 2, 3, and 4 just to help me get a better idea. So here's the X's. I look at the opposite side. So 1 and 3 are opposites. But for my answer, since this is a notes, if this was a homework or a test problem, I'm not given 1, 2, 3, and 4. I just put those in there to make the problem easier for me to understand. So I'm going to say what angle 1 is. So angle 1 is this HML. So I'm going to put HML. And now for angle 3 is JMK. So angle JMK. These are a set of vertical pairs. So likewise, though, for 1 and 3, I also have 2 and 4. So I have to say the other set is angle H, M, J, and angle L, M, K. So this is a set of vertical pairs, and this is a set of vertical pairs.